Y'all ready for this? All right. I think this is going to be the last video. It should be. I tried doing number 22 on the other video. I got a little messed up, so I had to edit the video, cut it at the end, and put it on here. But these things happen. All right. None of us are perfect. We have what looks like a rectangle, and they want to know the area of a rectangle. So let's draw that rectangle like we like to do. We know that area is the length times the width. So they give us the area, and it's 10w squared minus 6w minus 4. And they're telling us one of the sides, let's throw it on the top, one of the sides is 5w plus 2. So they want us to find this other side. Now, I know that when you multiply these two sides together, you're going to get the area. Now, these two sides are factors of the area because things multiplied together to get something else are called factors. So, in order to get factors of a trinomial, the classic old trinomial here, we're going to get out our big red X. And before we do that, we're going to do the first thing we have to do, which is to look for a GCF. We have 10, we have 6, we have 4. I'm not worried about the minuses with the 6 and the 4. We're looking for the GCF. We're going to look at the smallest number first. Let's see what the factors of 4 are. What multiplies into 4? 1 times 4 and 2 times 2. Now let's see if any of these numbers multiply into both of the other numbers. 4 doesn't work because 4 doesn't go into 6. It doesn't go into 10 either. But 2 works because 2 multiplies into 6 and it also multiplies into 10. So I do know that my GCF of the numbers is 2. Now, do we have a GCF of the letters? Well, we have a W here, we have a W here, but we do not have a W here. So we cannot take out a W. So the GCF is going to be 2. So we'll divide by 2, we'll divide by 2, we'll divide by 2. And we'll start that parentheses. 10 divided by 2 with a W squared is going to be 5, and that W squared comes down. Negative 6 divided by 2 with a W is negative 3 with a W. Negative 4 divided by 2 is a negative 2. All right. Now, we cannot hear bells and whistles in our head. No shortcut going on here. We are just looking at what we have in the parentheses right now, and it is that classic trinomial. So we cannot do the shortcut, but we have to do the rainbow. We're going to rainbow 5 times negative 2, and that is negative 10 up top. What goes on the bottom? Negative 3. What are my signs? One positive, one negative, because it has to be a positive times a negative to get a negative at the top. I do know they're going to do what to the bottom? Are they going to add to 3 or subtract? Well, because the signs are different, they're going to subtract. Let's get the factors of 10. 1 and 10, do they subtract to 3? I don't think so. 2 and 5, do they subtract to 3? Yes. Now let's be careful of our signs. It has to be a negative 3. It's going to be 2 minus 5. That gives us a negative 3. All right. We have the sides of our x. So now we get our shovel out and we dig out the middle. See ya, negative 3w. You are out of here. So we are going to take our first 5w squared. We're going to take our last negative 2. And then we take the sides of the x and we put them in the middle. Plus 2w minus 5w. Once we have the 4 terms, we factor by grouping. We're going to put parentheses around the first 2. We're going to put parentheses around the last 2. We're going to do the GCF of the first 2. 5 and 2, they don't have any GCF. W squared and W, that is going to be W as our GCF. we're going to divide by 1w. I throw a 1 in there because it's a little easier for me to see. 5 divided by 1 is 5. W squared divided by w is w. Remember, first and second are always going to have w's. The third will not. 2 divided by 1 is 2, and the w's are gone. What sign goes in the middle here? It's whatever the sign is of that third number, negative. 5 and 2, they do not have a GCF. And you're never going to have a letter in the middle here because 2 does not have a W with it. If they don't have any GCF, we do have to throw in a 1. And this is a negative 1. Parentheses, we're going to divide by negative 1. Negative 5 divided by negative 1. Positive 5 with a W. Negative 2 divided by negative 1 plus 2. All right. You know your two answers. One of your answers is the parentheses. So one of them is 5w plus 2. Your other answer is what you have if you got rid of the parentheses, which is going to be w minus 1. You throw that in another parentheses, w minus 1. But there is something that has to go at the beginning because you did take out that G, C, F. This guy comes all the way down, all the way down to the beginning. And that is your answer. But they want to know what's the length of the other side. You don't need the 2 as the length of the other side, but they gave you one of your answers up here, 5w minus 2. What's the other side? Is going to be w minus 1. W minus 1 is the other answer. All right, let's get moving to 23. All right, these I do find students struggle on. I see a lot of struggle with these. I'm going to be honest with you. I do. When I was your age, I definitely struggled with them too. But I did this a million times in the last bunch of years. So I think I figured it out. All right. So let's kind of compare this to something else. You got a big rectangle. All right. And let's say the whole area of this rectangle right here, everything in here is going to be 20. The whole area is 20. And let's say you had another small rectangle over here. All right. And let's say the area of this guy was 8. And now let's put this guy inside the other guy. All right. We're going to put this guy in here. All right. Let's put the 8 with it. And now, if I said to you, what is the area of just the highlighted area? Okay, just the highlighted area. Now, remember, the whole box was 20, but now I just want to know what the area is of the shaded green there. Well, to get that answer, I bet you know what to do. You would do 20 minus 8, and the area of just that green part would be 12. And that's what we're going to do here. We're going to get the area of the whole thing, right? To get the area of the whole thing, we're going to do the outside times the outside. Let's do that first. Let's get the area of the whole thing. Let's get rid of this. I don't need you anymore. I know, it's a lot of cutting. I just didn't want it up there anymore. See ya. All right, so we're going to get the area first of the whole rectangle, which is x plus 8 times x plus 4. We're going to FOIL this. We are foiling experts. X times x is x squared. X times 4 is 4x. 8 times x is 8x. And 8 times 4 is 32. What do we have to do with the middle? You know, we got to combine those like terms. And we get x squared plus 12x plus 32. This is the area of the entire rectangle. Now, what do we got to do next? We got to get the area of just that white triangle. Why do I say triangle? Rectangle. All right, so we got to get the area of that one. X plus 3 times x plus 1. X times x, x squared. X times 1, 1x. 3 times x, 3x. And last is 3 times 1 plus 3. We get x squared plus 4x when I combine these guys, plus 3. Now I have to subtract this green from this blue. So I'm going to write it out. X squared plus 12x plus 32 in parentheses minus another parentheses x squared plus 4x plus 3. Column time. All right. I'm going to rewrite this so I can do it in my columns. I know it's a lot of rewriting, but that's what I like to do sometimes. We have a minus, but we're going to turn it into a plus. And we have this positive x squared. We're going to do minus x squared. We have this positive 4x. We're going to do minus 4x. We have this positive 3 minus 3. Our answer, these x squareds, they are gone. Goodbye. They cross out. 12 minus 4 gives us 8x. Negative 32 minus 3 gives us a plus 29. Let me make sure I got that right because I did this before. This was number 23, 8x plus 29. All right, that's what I got before, just to double check. All right, next. These are fun sometimes. All right, so they want to know the total area of this figure. All right, I think with these, it's really hard to see until you see it, and then it's hard to not see it once you see it. So we have this side right here. I don't like that. That's too thick of a line. We have this side right here. That's 2x plus 1. We have this side right here, 6x plus 6. We have this side right here, x plus 2. We have this side right here, 3x. But we do not have this side right here, if you notice. And we do have this over here. So we are missing something over here that we have to figure out. Okay. So let's get the total. This is a vertical line. Let's get the other vertical lines. Let's check out the other. This is a vertical line also, right there. And then this is a vertical line. This vertical line, 2x plus 1, goes the whole way from the bottom to the top. This part, this vertical line over here, does not go the whole way from the bottom to the top. So if we're looking for this missing piece, we take the whole thing here, we subtract it, we subtract this, and whatever we have left is going to give us this part here. Let me see. Let me show you what I mean. This over here, let's say this part. I don't know. I guess we're bringing back the big red line, not x this time. This whole line is 2x plus 1. Let's go back to, and then this part of the line, let's say right here, just that part of the line, let's imagine it starts at the bottom, exactly where the other one does, is x plus 2. So we're missing a piece, and we're going to make that little piece over here. We're missing like from here to here. So what's left over? Okay, we're going to take the big line, 2x plus 1, and we're going to subtract x plus 2. When we subtract, remember, subtract x plus 2. Remember, when we do this, we have to do same, change, change all. So this is going to change to a plus. This is going to change, and this is going to change the signs. Minus x minus 2. This is going to be 1x minus 1. So this little part here now we know is 1x. I'm not going to put a 1 in this case. I'm just going to put x minus 1. That's that little part right there. Okay. Now that we know that little part right there, we do have to turn this into two different rectangles to get the total area. So there's a couple of different ways you can do that. You can make a horizontal line here, or you can make a vertical line right there. I'll do a horizontal line here. Let's do this. Okay. So we're going to look for the area of just this first square right here that I'm going to shade in green. I know it's a rectangle, not a square. I do get my shapes mixed up sometimes, but you guys know what I'm talking about. In order to get the area of that green part, we're going to do length times width. The length, the long way, is 3x plus 6. The width, the short way, is x minus 1. Let's multiply those together. FOIL style. 3x times x, 3x squared. 3x times negative 1, negative 3x. 6 times x plus 6x. 6 times negative 1 minus 6. We're going to do a little combo in the middle, and we're going to get 3x squared plus 3x minus 6. That's the area of the green. I'll write it in here. 3x squared plus 3x plus 6. Nope, not plus 6. That's a minus 6. 3x squared plus 3x minus 6. All right. Now let's get the, I'm going to shade the other one. We got a little highlight going on here. Purple. We're going purple. This rectangle, I got the shape right this time. Yay. This rectangle right here, we got to be careful. What is the length all the way across that one is going to be, let's change the color to blue. 6x plus 6 is the length. And what is the height of just this, or the width of just this rectangle here on this side? X plus 2. So we're going to FOIL 6x squared when we do 6x times x, and 6x times 2 is plus 12x. 6 times x plus 6x, 6 times 2 plus 12. Let's do a little combo in the middle. We get 6x squared plus 18x plus 12. All right, let's write that in the middle. We'll do it in red. 6x squared plus 18x plus 12. Now, we have the area of one rectangle. We have the area of the other rectangle. And to get them totaled, we are going to add them up. Let's move this right underneath the other one. And we're going to add the like terms, do the column thing. 6x squared plus 3x squared is going to be 9x squared. When we're adding, we do not change the x squareds. 18 plus 3 is going to be 21 with an x, and 12 minus 6 is going to be a plus 6. Let me confirm that's what I got before when I worked this out. I got 9x squared plus 21x plus 6. I do believe that's right. I did it twice and got the same answer, so I hope so. All right. Not too bad, hopefully. Desmos, last one, 25. All right, we're going to do a little Desmos going on here. All right. They want to know the equation that we type in for Desmos for linear regression. And that's just something you got to know. It's that squiggly stuff we got going on. Remember the y1 squiggly mx1 plus b. For the exponential, it's going to be y1 squiggly a b. We raise it to the x power and we put a little 1 next to the x when it's raised. All right, now we got one of these questions here. All right, it says we have 1997 is our starting year, but that equals year 0. So I'm actually going to put 0 here for 1997. 1, 2, 3, 4, 5, 6. And that's what we put in Desmos. We don't put in the years in Desmos because they want us to use 0 for 1997 and so on. All right. So we're going to go back and forth into Desmos. 50, 54, 58 are the first three. Here's our Desmos. We go to plus at the top left. We go to table. We're going to do 0 through 6. 1, 2, 3, 4, 5, 6. I think the first three were 50, 54, 58. 50, 54, 58, if I remember, because it's not that easy to remember for me. All right, let's go to here. 50, 54, 58, 63, 68, 73.5. 63, 68, 63, 68, 73.5. And you think I could have remembered the last one, but no way. 79.3. 79.3. All right. Now, we're going to throw in our y equals. So we have y1. That's squiggly. Nope, we got a shift for the squiggly. mx1 plus B. All right, that gives us some information there. We're checking out the R, all right? We're looking at the M, we're looking at the B, we're looking at the equation. We got some good stuff going on there. All right, so what does it want to know? It wants to know the linear regression equation, okay? So we need to know here our M, M, our X, and then whatever our B is. So we can round this to the nearest thousands. That's going to be three numbers after the decimal. So the M is down here, 4.889. Let's do 4.889. 4.889. We're going to put an X, okay, plus what is the B? It's 49.018. I'm going to round it to 49.018. 49.018. What does our R equal when we go there? Our R is 0.997. 0.997 is our R. 0.997. All right, the regression. All right, how do we do the regression? We talked about the formula before. So the regression is going to be y1 with a squiggly, a, b, raise it to the x power, shift 6 gets you up there, x1. I do have to hit that log mode to get my r. All right, and what we have here is, how do I get rid of this down here? I don't know, but I'd like to. I can see it. All right. So we have the A is 49.936. 49.936 is our A. All right. I didn't mean that. 49.936. Our B, I'm going to put in parentheses, is going to be 1.080. 1.080. 1.080. We raise that to the x power, and we have to find our r, which is 0.9999. I guess we can round it up to a 1 if we really wanted to, but I'm just going to put 0.999. We should probably, I don't know. Let's just leave it as 0.999. If you wanted to do it as 1, you're not going to be wrong. All right. Which is the better fit? Which is closest to 1? Which is closest to 1? Well, the exponential one is closest to 1. So the better fit is going to be your exponential one. Now, using that line, using the better fit line, when it says using that line, we are using this right here. And it wants to know how many people there are predicted to be in the year 2025. Well, what number is 2025? Well, 2004 would be 7, 2005 would be 8. Now I can keep going until I get to 25, or I can just do the year that they want, 2025, minus the first year, 1997, and that's going to be 28. So I know this X right here, I am going to use that X, and instead of X, I'm going to put in 49.936, parentheses, 1.080, and raise it to the 28th power. All right. I trust that you guys can do that and put it in your calculators. Actually, I might have done it already. Let me see what I did for number 25. I believe I did, just so I don't have to go back to Desmos and do it. I did. And your answer should be 432.7, but we can't have a fraction of a person. So we're actually not going to round up because we don't have a full person. So in this case, we're actually going to just leave it as 432. All right, we're good. That was a fun Sunday doing this videos, somewhat. If you have questions, please ask. If you have comments, please let me know. Okay, if it's too fast, too slow, don't understand anything, just let me know. And please make sure you're looking over this before your 100-point test coming up soon. Peace. I'm out of here.